All right, today we're looking at starting our unit on sequences and series. This starts with a review of sequences. An infinite sequence is a function whose domain is a set of positive integers. So you would plug in 1, 2, 3, 4, 5, so on to get the values of the sequence. Now sometimes we say it's positive, sometimes we can start with 0, so we're not going to say it's always positive integers, but that's a general idea here. So the first item is discussing writing the first 5 terms. So if we're starting with the positive integers, we plug in 1 to n, and we get 1 minus 1 is 0 over 1, that's 0. We plug in 2, we get 4 minus 1 is 3 over 2. Plug in 3, 9 minus 1 is 8 over 3. Plug in 4, 16 minus 1 is 15 over 4. And then plug in 5, 25 minus 1 is 24 over 5. Similar thing for the second one, just plugging in n 1, 2, 3, 4, 5. We can also write explicit formulas. This is more just understanding how these patterns work. Like for example, for this one, we see plus 3, plus 5, plus 7. Usually that pattern means that we're doing something to a power. And if we look, all of these are one more than the closest squared. So this is 1 squared plus 1. This is 2 squared plus 1. So it looks like our formula is going to be n squared plus 1. Similar thing happens for number 4. On top, we see a sequence of just numerically increasing values. So 1, 2, 3, 4. And on the bottom, we see the same thing. But the top is always one more than the bottom. So we can say it's n plus 1 over n. For number 5, on the numerator, we see a sequence of odd integers. On the denominator, we see a sequence of even integers. So we'll just create a fraction that the top uses odd integers, starting with n equals 1, and the bottom uses even integers, starting with n equals 1. And then lastly, for number 6, this is the toughest of them. So the top is just the list of squares, so n squared. The bottom is an interesting sequence. We need to know this one because of this unit. It is n factorial. That's one that might show up pretty often, so you have to keep an eye out on it. All right. Talking about factorials, we can also talk about simplifying factorials. This usually just involves expanding it out and canceling. So like for number 7, this is n times n minus 1 times n minus 2. So every time we expand, we just subtract one more. And we'll just say factorial because it keeps going down. On bottom, we have n minus 1, n minus 2, and then look, n minus 3 factorial. So from here, it's going to repeat. And so we can cancel these out on top and bottom, and we're just left with n. Similar things for 8 and 9. Last thing we need to talk about is the terms of a sequence and what they do. Sequences are said to converge if they approach a finite limit. So that just means if the limit is finite, they converge. If it's not finite, they diverge. So like for example, this first one, limit as n goes to infinity of 1 over 2 to the n, that's equal to 0. 0 is a finite number, so we say it converges to 0. Whereas for b, if we do limit as n approaches infinity of 3 plus negative 1 to the n, if we look at what's going to happen, this is going to keep alternating back between a positive and negative. So it's going to be 3 plus 1 or 3 minus 1, which means it's always going to alternate between 4 and 2. That's it. 4 and 2, 4 and 2, 4 and 2, back and forth forever. So this is going to end up equaling does not exist, or say it does not exist. So since it does not exist, since it's not finite, we would say this limit diverges. Technically, it diverges by oscillation. Okay, so finding if the sequence converges or diverges, that's all it is. It's just finding the limit. Aside from that, there's nothing really else that we need to go over. Tomorrow, we'll look into more of the calculus side of things and what we're going to be doing with it. Let me know if you have any questions. Y'all have a great day.